Hi, I am Shafqat. I am a lecturer in mechanical engineering and design at the University of Northampton. Uh, I am presenting this presentation on the behalf of Dr. Muhammad Khalil. So, in this presentation, I will be presenting the research outcomes of our investigation at computer-aided structural analysis of the lift car frame system under emergency rust operational conditions. Here are the outlines of the presentation. So I will give some short introduction of the topic. Then I will give an account of car over travel and emergency arrest. And there will be FEM results and simulation on the structural analysis of the car frame assembly. And finally, I will conclude my presentation. So the dynamic loads acts upon components of a lift system during normal operation and as well as during emergency conditions. So this dynamic load uh, can cause very high level of stress, dynamic stress in the lift car frame structure. Um, to meet the criteria for acceptable surface, the stresses and the deformation analysis is very important and is required in conducting the system calculations. So the main aim of this work is to demonstrate a computer-aided solution and analysis of the dynamic response that arises during an emergency scenario. Uh, for example, car travel and emergency arrest. So, car over travel and emergency arrest. So we have presented a scenario here when car is striking an emergency dissipation buffer. So it's car of mass M and is hitting an emergency buffer, which is a very renowned spring and dashboard system. So the fundamental mode of the car frame buffer dynamics when the car is traveling at velocity v and hit or engaged with the energy dissipation buffer. So, so it's described by this equation. And if we solve this equation, then we can find the force acting on the buffer during the buffering event, and that is given by this equation. And for structural analysis of the car frame analysis assembly, we use the finite element analysis here, and the behavior of the structures is represented by the same equation, equation 1, but this time is represented in the matrix form. So we have mass matrix, uh, damping matrix, and stiffness matrix. So we also develop a CAD model for the FEM analysis. So CAD model assembly comprises of buffer channels and buffer plate, platform, and we have car enclosures. So here, the fundamental mode of the car frame buffer systems were described by equation. The same equation number 1 is written in the form of fundamental mode parameters, that is damping ratio and fundamental frequency. And after solving this equation for velocity of 2 meters per second and for two cases of damping ratio, that's 0.25 and 0.75. So we get results for deflection in the frame. So below lines are for 0.25 damping ratio and the red one for the 0.75 damping ratio. On the right hand side, the results of the force acting during the buffer event. Here are the results of the simulation, FEM simulation. And so during the simulation, you can see the bending stresses are produced in the assembly. And so they are presented here, represented in both cases of the damping ratios. And here the result of the simulation, FEM simulation. So the bending deflection levels are presented. So there are significant level of bending deflections uh, 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 are occur during the buffering event in the frame assembly. So here are the conclusions here. So when there is a is emergency rust event triggered by the car over travels, so large deformations and stress flares may occur in the lift system. So these stresses and deflections in the buffer channels must be assessed for the worst case scenarios during the operation of the lift here. So this might happen or occur during buffering event as we have demonstrated in our paper. Thanks for listening. See you soon during the event.